Om Swastiastu. Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, my name is Sanquerio Putra Freitas with student ID number 22055311103 from Metalurgi Praktikum Mechanical Engineering Udayana University. And in this video, I will explain about 4 points. The first point is the tension test, the second point is the hardness test, the third point is the impact test, and the fourth point is the metallography. And this is my main reference, this book by Sarah Kalpajikan and Stephen R. Smith. And this is the content as I said before, and this is the first point, tension test. Tension test is the most common method for determining mechanical properties of material, such as the strength, the ductility, the hardness, modulus of elasticity, and strain hardening ability. And in this tension test, we usually use this machine called Universal Tension Machine or UTM. And from that machine, we can get this graph. And from this graph, you can see in this y-axis there is a stress, and in the x-axis there is strain. And there is a green line here, and there is some multiple dotted line like this. This is yield stress, and this is UTS or ultimate tensile strength, and this is plastic area. This is elastic area. The elastic area is when the specimen will go to its normal form when get pressure or when get pulled by both sides. And the plastic area is when the specimen will not back to its normal form. And in this plastic area there is a necking. It's near the ultimate tensile strength, and the necking is like this when the specimen is going to fracture. This is the formula. The stress formula is arranged with force or load divided by area, and the strength is L minus LO divided by LO, which L is length of stress and LO is original gauge length. And this is the modulus elasticity, E equal to stress divided by strain. And this is the formula. The elongation equal to LF minus LO divided by LO times 100, which LF is the final form for the L, and the LO is the original length. And in reduction of area, there is AO minus AF per AO times 100, which AO is the original area minus AF is the final area divided by AO original area times 100. And the next is hardness test. Hardness is a test to see hardness of material to determine the nature of its mechanical of a material. To test hardness of a material, you can use following methods. First is Brinell test, the second is Rockwell test, and the third is Vickers test. The Brinell test is introduced by J. A. Brinell in 1900, and this test involved pressing steel ball or total ball with diameter 10 mm or 0.4 inch to the specimen. And this is the weight of the tungsten ball is from 500 kilograms to 3,000 kilograms. And this is the machine that we use. This is called electronic Brinell hardness tester, and the specimen will put here. And the second is Rockwell test. The Rockwell test is the test to measure the penetration depth, and it's not the diameter of the indentation. The indenter is pressed to the surface, first with a small load and the second with a large load. The first load is the diamond cone, and the second is the steel ball with diameters. First is 1 per 16 inch, and the second is 1 per 8 inch. And the weight right here, and this is the Rockwell hardness tester machine. You can see this is a dial face, and this is the penetrator, and this is the anvil when the specimen goes, and this is the wheel, and this is the crank to release major load. And the third is the Vickers test. This test is developed in 1922 and the previously known as diamond pyramid hardness test, using an indented pyramid shape diamonds and weight that range from 1 kilogram up to 120 kilogram. This is the degree 136 degree, and this is the weight 1 to 120 kilograms, and this is the machine Vickers hardness tester. And the third test or third point is the impact test. The impact test is a test of material by means of instantaneous loading on the test material or specimen. In the impact test, there are two ways, namely first Charpy test and the second is ISO test. The first is Charpy test. Charpy test is impact testing by placing position of the test specimen on the support with a horizontal or flat position and the opposite loading direction with the direction of the notch, like this picture. This is the starting position, this is the hammer, and this is the specimen where the hammers will go here, and this is the end of the swing, and this is the scale, and this is the specimen. And in the ISO test, is the test tumbling by placing the test specimen on the pedestal with position and the direction of release in the direction of the notch. So this is like this picture. And then the next is metallography. Metallography is studying the microstructure of all types of metal alloy. So the metal surface and the faults that check with naked eye or with a magnifying glass or microscope, metallurgy, or binocular. So the surface of microscope applies or edge surface at magnification ranging from about 100 to 1,000 and 1,500 diameters can reveal information such as grain size and shape, distribution of structural phase and non-metallic inclusion, microsegregation, and the other structural condition. Some of the earliest relationship between microstructure and macroscopic properties established in metallography using light microscope include general increase in yield strength and hardness with decrease in grain size, anisotropic mechanical properties with elongated grain and favorite grain orientation, the general trend of decreasing ductility with increasing inclusion content, direct influence of inclusion content and distribution on fatigue crack growth rate or metals, and fracture toughness parameters or ceramics, and the association of failure initiation sites with material discontinuity or micro feature such as second phase particles. That's it. Thank you for watching my presentation. I'll see you later.